Hello and welcome to Cooking with Unity. I'm your host, Maximilian, and tonight we're going to wrap up our tower defense game. So, hopefully you guys are seeing the screen now. I really need a second monitor so I can see what's actually going on. So, on the last episode, let's open up our test level here. By the way, if you didn't join us for our previous episodes or you didn't get around to actually doing them, you can follow along. I've put a link on the chat window on the right-hand side, and if you're not watching live, you'll have that link in the description for this episode. So, our last episode we had 2 towers working, and you can switch between them, and we have 2 enemy types, though they're very similar. And one of the dudes slows down enemies, and the other one shoots them. Both actually do a small amount of damage, but the slowdown has an additional effect. And we have enemies, we have them pathing. We don't have a little base icon. I guess they're just going to go off the screen and count as against you. Because I don't feel like doing art. Not that I couldn't just put a sphere there or something. So, yeah, that's what we've got so far. So, let's wrap this up today. What I want to add is we're going to add our third tower type, which is going to be some sort of mortar indirect fire weapon with splash damage. And the other thing I want to do is add like some very basic scoring / resource system to the game. And we'll see how that goes. So, let's start with that tower. We already have a third tower. It currently works exactly the same as our first, I think. So, if we put these, they're exactly the same as the green towers. They even shoot green projectiles for no reason. So, let's change the behavior. We're gonna get a little bit more complex on this one. So, our basic enemy script. This is not what we want. Basic tower script. What it does is it spawns bullets. What is this thing that's doing here? Target equals. Oh, this is for figuring out what it's targeting. This is our target code. So it targets something. Once it finds a target, it fires bullets at them. And it does this according to its fire rate. So at any time that this is invoked, it will decide which enemy to attack by just picking the first one in the list of things that are within its range, and then it fires a bullet at them. And all it does, we're not doing anything fancy on this one. It just adds a force in the direction of the enemy, and it fires directly at them. It doesn't do any leading or anything. And the bullets are firing fast enough right now and the enemies are moving slow enough that doesn't really matter. And you might even want it that way, just so that your basic towers are not as powerful against the fast-moving units, so that it encourages you to have the slowdown units or different fire rate attacks. So what we're going to do is I'm going to duplicate this basic tower script. I'm just going to hit Command D. Control D if you're on Windows. And I'm going to wait for my computer. Alright. And we're going to do, let's see, I'm going to call it mortar tower. And this one currently does exactly the same thing. All you have to do is make sure to change it to mortar tower here. And we should be able to just attach this to our blue tower. Oh, it hasn't finished compiling. Oh, why did it move? Stop that. Let's try that again. Okay. It's funny that it moves if it can't actually attach. I'm going to hit play here real quick so that it forces it to compile. Alright, there we go. So I guess my computer encoding the stream makes it a lot slower to get things compiled. So I'm going to remove the basic tower script, and it just is going to have the mortar tower script. And it's going to work exactly the same again. Oh, wait, not yet, because we need a projectile for it. So let's duplicate our bullet and call it mortar. Is that even how you spell mortar? Probably not, but whatever. It'll still work, even if it's spelled wrong. And I'm just going to real quickly make this use the blue so that it matches the tower. You do not have to have such gauche color schemes in your games. I just do this for ease of readability. You can always go in later and desaturate everything and make everything actually look cool as opposed to the way I make things. So, it doesn't have a bullet, so we need to actually assign the bullet. Whoops. Blue tower. We assign mortar to our bullet, and we should have it shooting at least blue bullets now. It will work exactly the same as before. So the green tower shoots green bullets. Blue tower shoots very slow-moving blue bullets, so that's fine. It has different settings here, and that's the reason that it's operating so strangely. That's funny. It's not as effective, is it, to have them going so slowly? I like how the fast ones are actually just running into them. All right. Let's see what we can do to make this awesome. So our mortar tower, what we're going to be doing is we're going to be lobbing the bullets. So we're going to actually use that third dimension there a little bit. Everything else has been kind of working in this same plane, this 0.5 above the plane on the ground. And I just wanted to add something that's a little visually distinctive, and it purposefully delays the effect of the attack. We may add leading code, depending on if we need it, to make it more effective, but we're just going to try lobbying it in the direction of the enemy so that it lands where the enemy at least was. So how do we do that? So all we're really changing is the way the bullet moves. And our bullets right now are kind of dumbfire. And what I mean by that is you shoot them. We're just applying a force. That's what this is doing. New bullet.ridgebody. And actually, let me make this slightly bigger for people to see. How do I do that? Nope, wrong one. There we go. Doesn't need to be that big. All right. So, yeah, all we're doing is we're instantiating our bullet, and then we're adding a force to it, just in the direction of the units. What we're doing here is just a little bit of math to determine the direction. This our target's position minus our position, and then normalizing it, adding our speed, multiplying in our speed, and it's doing a velocity change, so it doesn't care about the mass of the object, and we're probably going to be keeping that for this one. So what we want to do now is we want to get it so that it goes up in the air and then comes back down and then lands on that spot. And so there's two aspects to this. There's how high it goes in the air and how far it needs to go. And so basically we're trying to figure out a speed for the amount of time that it's going to be in the air. I'm hoping explaining that well. I'm going to add another variable here because we need to determine how high we want these things to actually go. So we're going to do bullet lob value. Why not? Lob amount. It might actually change to lobbed force later. I may not change the name, but that's probably what it's going to actually be. We're going to need to make a force vector. We're doing that here with our math, and we're going to do it a little bit ahead of time just so that we can kind of break out how it works a little bit easier. So I'm going to do it as basically adding two force vectors together, the vertical component and the horizontal component. So the horizontal is is based on the vertical. It's really based on how long it will take to land. So we may have to actually have our gravity in the calculation as well. Do we have access to that? Physics.gravity? Yeah, we do. Excellent. It's a vector. Perfect. So we're going to have to figure out how long it takes to land and then determine our speed from that. So force equals mass times acceleration. I always do really badly at math when I'm doing it on the show. Actually, that's a lie. I do bad at math when I'm doing it by myself, too. So we have our lob amount. Let's have that be the vertical force. So we'll just do, we're going to make a new vector 3 force equals, let's do the initial thing at, let's see, vector 3 force equals, let's just do vector 3 dot 0. God, why my mind is just going blank right now. Vector 3, can I just do a constructor? Is there some trick to that? Do I have to do new? Vector, yeah, there we go. Alright, so actually let's put that up here. It's really basic stuff. I'm kind of embarrassed that I wasn't just typing that out first. Vector 3 force equals new vector 3, and we want the x and y to be 0, and the z we're going to make 1.0 f. Well, no, sorry, lob amount. Use those variables. And so then we need to figure out the, let's call this vertical force. We may compress this a little bit once we work it out. So that's our vertical. We're not taking mass into account, so that's actually setting the vertical velocity. If we're doing the velocity change mode, which is what we're going to be doing. It will immediately change velocity to that. Force equals mass times acceleration. We're not worried about We're not worried about mass anymore, because we're taking that out of the equation with a velocity change. I'm going to break my brain on this. I guess I'll just start typing stuff and we'll tweak it till it works. Vector 3 horizontal force equals, so if I have a vertical force, it will reduce, it'll go up and it'll reduce based on gravity. Alright, we're trying to figure out T for an equation. Force equals mass times acceleration. Let's type it out. F equals m times a. That's not what we actually want. To the internet. Alright. Solving for time with regards to gravity. Let's just use plain text and see what we get. Oh, calculus. I don't want to use calculus. Maybe I have to use calculus. Let's see. I guess we do have to use calculus. Wow, I am bad at math. Alright. Let's just fudge it. Why not? We're going to have lob amount in here somewhere. Just going to put that in there, even though this makes no sense right now. Let's do a new vector 3. And so it's going to be the X and Y. So we're going to need the direction, right? So actually, let's make it this first. Direction. I'm just messing everything up here. Sometimes code is messy as you're making it. Target transform position minus target transform position. Sorry, just minus transform position normalized. So we're going to need a speed. Let's just make a float speed. We don't use speed anywhere, right? Equals, let's do something really stupid at first. Lob amount times physics.gravity. The people who are just holding their heads at home watching this are like, oh my god, he has no idea what he's doing. And he doesn't. I have no idea what I'm doing. So, but that's okay. I've made plenty of things work when I had no idea what they were doing. This doesn't make any sense, but we're doing it. Lob amount times physics.gravity. Why not? And that doesn't actually make any sense because that's not even a float. This is, so we just want the y component. Wait. Yeah, the y component, actually. And so that means we need lob amount in y. That's our vertical. This is our that's into the camera if we hadn't moved above everything. So, what we do is we actually make the final equation here, which is vertical force plus horizontal direction. And then we put this in brackets, even though it's not necessary because it's multiplication, so obviously it will happen first. But I just like to be explicit. Times speed. And let's see what this does. This is probably going to be awful. Wait for it to compile. There we go. Well, didn't get any compile errors. That's cool. Yeah, it's doing things not like we want. Is it even changing the vertical? Let's take a look at the scene. Yes, it is. Yeah, I think we want to use a divided by, not a times. Let's try that. Neither of these actually make any sense, I don't think, but we'll find out. Ooh, that's looking closer. Oh, is there no gravity on these things? Oh, that's right, I turned off gravity on the motors, on the bullets. So we actually want gravity this time. So let's see what we get this time. Now it's not even getting out of the tower. I don't think. Yeah, they're just dribbling out. Alright. Let's do it the tweak method. Alright. As I said, I've done more projects than I knew I was doing, so here's how you can get away with that. So, public float, oh, we already have bullet speed. We're not using that anywhere, are we? Okay, perfect. We'll just use bullet speed and lob amount, and I'm going to group them together so that we know we need to tweak them together. This isn't going to work in every case this way, is it? Because if they're far away, we want them to be going farther. Yeah, so this isn't going to work. Again, sorry you guys that I'm just struggling through this naturally in front of the camera. Let's make the lob amount much higher. Let's do 10. And actually, let's do 50. Let's make it rain. All right. Probably wasn't getting enough power anyway, so that's good. Not doing so good, is it? These aren't colliding with this, are we? We don't have the tower tagged. Is that a problem? Or wait, it's not tagged. It's layer default. Is that what we want? Okay, that's what the other ones are using. All right. Anything special about the bullets? They're marked right. All right. All right. Let's make this work. Alright, let's try 1,000. When in doubt, make the numbers really ridiculous. And actually, maybe I should actually check to see if we're changing anything. I just realized that if we've adjusted anything on the mortar, it might not be taking those default values. On the blue tower. Yeah, that's our problem. It's not even caring about those values. Let's go back to our defaults and let's just adjust it in the game. I don't know why I wasn't doing that. Anyway, so hit play. We're going to adjust, because this will only affect things before you spawn them. So let's do lob amount 10. And put one of these down. There, that's looking more like something. Hard to tell exactly which one is aiming at. Maybe I should have it do something visual for that. It's not looking too bad, honestly. Let's try 50 for fun. That's way too much. Does it actually land back down anywhere? So obviously my math is wrong, considering I'm not doing any. Well, I mean, I'm doing something, but it's... I don't know what that does. I'm just dividing things for no reason. Lob amount divided by pixels, that could be bad, because I think this could be negative. Let's actually try that and see what happens. Guess and check. Yeah. Okay. Yeah, those aren't coming back down. We'll just put it back down to the low value and call it close enough for right now. Yeah, it's getting kind of close. Yeah, that'll work. Alright, so our bullet. Do we have any bullet AI for these things? Our basic bullets don't have any AI, right? Yeah, the enemies just handle that. That'll probably work to our advantage anyway. So let's give our mortar some AI so that it explodes. Yeah. So, let's create a new script. create C# script. Mortar AI. And we're going to open it up in MonoDevelop. And here we go. So what this thing's going to do is we're going to have an on-collision event. And we're going to, what is it called? Collision. So this will activate on collision. Currently, what do our balls actually collide with? I'm going to go into our project settings, physics, and check that real quick. So our bullet collides with enemies and nothing else. That's all it collides with. So let's see. We're going to want it to also collide with the ground, so this will actually work. So what I'm going to do is I'm going to create a new layer and put the ground in that layer. So let's click on our ground. We're going to click on layer, add layer. I'm going to call it, ground. And then we're going to put ground on here. Okay, go ahead and save the scene. And save the project. So now we're going to go into physics, project settings, physics again. And we are going to, what is it called? Make the bullet collide with the ground. Everything else we don't want to care about the ground. So we should still see it colliding with the ground. I guess it was doing that before, but I didn't fully trust it, so this is not working right. But it's doing something, so that's better than nothing, and at least it gives us the illusion of depth. I'll get the math working by the end of the episode, I think. I'll actually do an honest effort at looking it up. So what these things are going to do is they're going to spawn an explosion and destroy themselves. So I'm going to create a public game object explosion, and that's really all these are going to need. And so when they collide, we're going to have them instantiate explosion, and we're going to instantiate it at let's do it at the point of impact. So contacts just 0. So this is ignoring all the contacts except for one. It'll work in this case because spheres tend to only collide at one point. You might have to readjust that if you were doing more complex models, but you probably are going to do sphere collision on these things anyway, even if you had a fancier model. So we're going to instantiate that. Oh, that's not going to give it anything. Position? No. Point. Yeah, there we go. That's the actual point. And quaternion.identity. We use this a lot. It just means whatever. It just means no rotations, just 0, 0, 0s all around. And then we're going to destroy our bomb. So destroy game object. So that destroys whatever this script is attached to. So we're going to hit save. We're going to attach this script to our mortar bullet. And then, so that's working. And then we need an explosion. So I'm going to create a new game object. It's just going to be a sphere. And we're going to make it, do we have a transparent blue? No, we don't. We're going to make a transparent blue real quick. Duplicate that. transparent blue, and we're going to make it 50%, 128. We're going to do the standard sphere explosion. So we have the sphere. We're going to give it the transparent blue, which is actually not going to work because it's still set to diffuse. So we're going to set this to transparent diffuse. All right, there, now it's transparent. And I'm just going to put this at 0, 0, 0 because we're going to get a prefab out of it. And let's make it small to start. So we will, we'll make this thing real small. Actually, let's just leave it at 1, 1, and we can adjust it in our script. So this is going to be called explosion. And we're going to create a prefab by dragging it over here. I'm going to put it in bullets, even though it's not technically a bullet. But it's a good enough place to put it. And deleting it from the scene because we don't need it in there. Alright, so we have our explosion, and we're going to need a script for it. What we should do is, let's just make a script that makes it grow. So, C# script, we're going to call this scale over time and destroy. That's an apt name for an explosion. It scales over time and destroys. Although I was saying that as it destroys itself, but we'll let the enemies handle them being destroyed. It'll probably just work too. That'll be just awesome. Actually, maybe not. It'll probably just do 1 hit point of damage, so we'll have to adjust it a little bit. But let's give it a shot. So, scale over time and destroy. We're going to need a few variables. Public. Let's do float time. Public float initial scale. Public float in scale. And so in our start routine, we're going to what is it called? We're going to do an invoke, or are we going to do a coroutine? We're going to do a coroutine. So start coroutine, and we're just going to call it scale. Let's call it scale over time. Scale over, man. Scale over. All right. Bad reference. Void scale over time. This is a coroutine. This is going to run continually until every frame it's going to get a chance to run and then a chance to yield. So this thing's going to have time, float t. This is our basic timer that we're using. And while t is less than or equal to time, let's set the default time to 1.0f. Let's set the initial scale to 1.0f. And set the end scale to 10.0f. So there's some meaning to it. Actually, let's make it much smaller. Let's make it 0.1. And let's do 5, whatever. Something somewhat meaningful, so we'll see something working. Oh yeah, and we actually need equals here. Equals is, yeah, that's the plural of equals. So, while t equals time, we are going to use alert function. So new scale equals, actually I'm going to create the variable here, float scale equals math f dot lerp. Oh god, I just did something very slow and weird. Okay, there we go. mathf.lerp from to t. So our from is initial scale, our to is end scale, and our t is t. Sorry, it's not t. That would be too easy. It's t divided by time. So what this means is it's a percentage to this time. And well, what do we need above this? We need to actually change t. So t equals time, no, plus equals time dot delta time. And that'll actually make this t variable useful, and it'll eventually actually get out of this while loop as opposed to just staying there forever. And finally, we do yield return null. And that should do it. Oh, and then after this, we destroy game object. Oh, wrong type of game object. Game object. Lowercase game, uppercase object. The other one is the type. This one is the actual object that this script is attached to. So we're going to click. There's something wrong. Cannot be an iterator block because of void. Oh, sorry. For coroutines, you need to use I enumerator, not to be confused with I enumerable. So this should do. Nope. Use of aside local variable t. Oh, t equals 0. Right. Easy enough. Didn't think Unity cared. Scale is assigned, but its value is not being used. Why is it not being used? Scale. Oh, I'm glad that warning was there. So I got this warning. I'm gonna hit play again, and hopefully it'll show up. No, it's a warning, so it doesn't show up anymore. It was warning me that I'm setting scale and then not doing anything with it. So what we actually need to do is we need to change the scale of the object. So we're going to change, what is it called? Game object dot scale local dot transform dot scale local scale equals new vector 3 scale. Now this thing should totally work, but don't hold me to that. I make too many mistakes as it is, but everyone makes mistakes, and that's the whole point. So here we go. We got this. It's on the explosion thing. Let's see if all our stuff works together and does something. Oh wait, did we actually set the explosion here? So mortar explosion needs to be explosion. All right, that should be everything. So if we did things right, these things should launch balls that hit the ground and do nothing. Yay, it's juggling. Alright, yeah. It's actually creating explosions? Let's find out here. So we got basic enemy. I don't see an explosion spawning. Alright, let's see what our mortar code has in it again. Oh, wait, no, instantiate explosion. It should be doing that. Alright, let's make, instead of explosion, let's have it spawn another bullet. And we'll see if it's actually spawning anything. Okay, spawning things. So that probably means that I'm doing something wrong with the other script. So let's switch this back to explosion, and let's turn off the scale over time and destroy and see what we get. Troubleshooting time. Alright, so it's actually making our things there. So obviously I have something wrong with the explosion script. So, as I said, thought it was going to totally work, didn't I? And there we go, it didn't. Start crew routine, scale over time, float t equals 0, while t is greater than or equal to time. We want less than or equal to time. That would be the problem. I hope that's the only one. So we turn this back on, and we give it another shot. So here we go. Bam! Look at those big explosions. Awesome! Alright, things are working now. It's colliding with... What is it colliding with? Are they colliding with each other? Why are they lobbing so badly now? Oh, I see. The explosions are triggering things for some reason. What? Oh, because the explosions are on the default layer and... Wait, do our bullets collide with the default layer? Yeah, probably. Wait, do they? Yeah, probably. Ignore all but raycast. Let's look at our physics again. So, project settings, physics. Bullets collide with ground, bullets collide with enemy, and default collide with bullets. That's the reason they were hitting the ground before. Yeah, we'll make the explosion a separate thing. What is the enemy use for determining how it gets killed? We'll make these super powerful. We'll just make them destroy the enemy. So, scale over time and destroy. We're gonna put an on collision event on here. On collision void on collision enter collision. Alright, so on collision enter. Man, I've taken a long time tonight and gotten very little done. I'm sorry about this. On collision enter, collision. We are going to just destroy the collider if it's an enemy. So if collision dot tag collider dot tag equals enemy. Just gonna hard code it. If it equals the enemy, destroy collision dot collider dot tag. Sorry, collision dot collider dot game object. Alright, so now this will kill enemies real nicely. And the other thing I wanted to do is so it's not impacting itself. So we're going to call the explosion on the explosion layer that we're going to create right now. So explosion, layer 12 is explosion. I just realized I should probably be doing this slower because I'm not sure if the screen's updating properly. I still haven't gotten that all figured out yet. So apologies if there's been stuff that's been hard to follow. So that being said, I'm going so slow on this episode, it probably doesn't matter. Scale over time and destroy. Oh wait, no, we want to go back to our physics little matrix here again. So explosion, we want to collide with really everything should collide with default. It's just safer that way. We don't want to collide with bullets. We want to collide with enemies. And we don't want it to collide with explosions. That's basically all we want it to do is hit enemies. So let's see if this works. If it works, we should see big explosions that kill enemies outright. And they don't. And we still have them hitting each other. Why is that? Because I didn't actually set their tags. I always forget that. So, for some reason, the reason I always forget this is because when you go in and add a layer, it doesn't actually apply that layer to what you are editing. And I understand why they wouldn't bother with that, but it gets me a lot, and it may get you a lot. So I just want to let you know, be wary of it. So now they're no longer setting each other off. That's cool. They're still not killing our enemies, though. Our enemies, do they have... Oh, okay. So I think we need to have a rigid body on these things. So let's do that. Physics, rigid body. Except for we're going to make it really lame. It's just going to be... is kinematic, I guess. Let's see if that works. If this doesn't work, we'll do freeze position, but this probably will work. Nope. Okay, let's try freeze position. There's a lot of rules to what actually counts as colliding between two things, and I haven't quite gotten the full grasp of it. I'm sure there's perfectly good reasons for everything. Yay, it's killing things! Alright, so now we have our completely ridiculous and overpowered mortar launchers. So let's... what are we going to do to adjust these guys? 15 minutes left. Let's make these guys fire a little slower, just so that they feel a little bit less ridiculous. So the blue towers are going to have a... I'm not even using bullet speed. I'm going to pull that out of there real quick so that we don't step on it. No bullet speed. And we're going to change the fire rate to be 0.2. And the fire radius we're going to make bigger, maybe? Let's find out. Oh, maybe that's part of my math problem. Times speed. Where's speed? Lob amount. Oh, okay. Well, I'm doing something. Yeah, let's give this a shot again. Let's see if these things are ridiculous. Oh, that was the wrong way to go with it. Yeah, that looks cool too. That's actually a very cool effect. Good way of testing to see if it's trying to hit on target or not, which is obviously not right now, but it's good enough for right now. Let's put this to 2. What are we doing for our yellow towers? 1. Yeah, that's perfect. So 2 seconds is an eternity in these games. So 1001, 1002. Yeah. Still going pretty fast. Oh, the fire rate. Make it 3. Still wanted it to be a little bit less powerful. Well, I mean, it's super powerful, but alright, so they're working. So let's see if in 10 minutes we can add what we need to make it so that we have amounts that we need and points and stuff. So let's make a quick resource manager. That's a bad name for it. Let's call it inventory manager. And all this will do... Oh, that's what we should call it. An energy manager. I'm going to rename it. Energy manager. And then we're going to change it over here because otherwise Unity will complain at us. And we're going to have... Where did it go? Okay, let's open it again. Public float initial energy, and we're going to do, let's see, public game object energy display, and we're going to do public game object energy display private float energy. And let's see. So we're probably going to be weak on the user feedback on this one, but let's get it done. So at the start, we set our, let's do private, let's just do public static. Public static. It's easier to understand what I'm doing then. Public static float energy. At the start, we set energy equals initial energy. And that's really all we're doing. We're basically just doing this to store a variable and display it on the screen. So actually, we do need an update to display it on the screen. So update. We're going to do energy display dot get component. I think we're going to be using a text mesh on this, so text mesh dot text equals energy dot toString, and we'll set the initial energy to 500. And so now we need to make a quick little display thing. So where's our UI camera? Let's find this thing in the universe. So just hit F a couple times. There we go. God, it's orthographic, so it doesn't matter. These things aren't in the same area, but it's just kind of funny to me that they're like that. So honestly, it's really stupid to do 3D text in orthographic camera, but I don't care. Actually, it's still good just because its positioning is easier. So we're going to do we don't want a component. It's much easier to actually create this wholesale by doing GUI text. No, not GUI text, 3D text. So we do 3D text. It's probably going to throw it in front of our camera a little bit. There we go. That's pretty good. Hello world. Not a bad spot for it. We want this to look better though. So what we can do is we can make the font size bigger, and then scale it down. Probably doesn't matter to scale that there. And so it's called, it just says hello world. Let's see how that actually looks on the camera. It's going to be in a bad spot. Alright, so we're just going to put it, kind of somewhere in there. Make it a little smaller. Upper left, alignment left. That sounds good. Let's make it 0.05. And actually, we'll keep the Z at 1. Hello world. Alright, let's put it like the top middle of the screen and actually make it middle center and center. Go into the scene, drag it a little bit. Yeah, good enough for me. We'll just put it up there. So X, we're going to copy that. Hit stop, put it there again. And, alright, so now we just have to apply, we have to have this script on something. Let's just create a new game object called empty game object. Create empty. We're going to call this the energy manager. We're going to throw our energy manager script on there. And then we're going to set the energy display to this new text. It's going to be called energy display. And we're going to throw it into our energy manager. And so if we hit play, it should say 500 if everything's working right. It says 500. Excellent. It doesn't matter what this says ahead of time. You might want to set it to 0 or something. I'm going to do that real quick, just 0. So at least if it doesn't get set, you'll know something's going on, and it won't look really stupid. So now let's make it so these things cost energy, and the enemies give you energy, and then we'll call it good. So the costing is pretty easy. When we spawn, what's our script for spawning the towers? Create tower unclicked. So, public tower selector. All right. Get selected tower. We're going to need to change our tower selector slightly. We're going to have add another function here. So, get selected tower, return tower, selected tower, public game, public float. Honestly, we should be using an int for this. Public int. And actually, let's change that in our energy manager. This is going to be an int. Doesn't really change anything else. Public int get selected tower cost. And we're going to create another little array here to just correspond with everything. Except this one is going to be an array of ints and tower costs. And it is an array still. So return tower costs selected tower. And then we're going to go back to our create tower clicked, and we're going to say if energy manager dot energy is greater than or equal to the cost, tower selector dot get what is it? Get cost. Get cost. Get selected tower cost. There we go. And then we set that. Okay, so if it's greater than or equal to the cost, we spawn it, and we remove the energy, which again we can get out of that cost thing. Energy minus equals the cost. And then what else do we need to do? That's it. Alright, so that'll make it so it'll subtract the power. So now we need to go to our whatever's running our tower selector script, which is energy matter, enemy spawner, no. Where did we put it? It's on our UI camera. Okay, that makes sense. It's a UI type thing. So we have tower costs, and they're all 0 right now. So we want this to actually be 3, and we want first tower is going to cost 100, second tower is going to cost 200, and the third tower is going to cost 250. Why not? And we're not displaying that anywhere to the player, so that's kind of unfortunate for them. So now when we hit it, we get a tower, we do one of these, we get another tower, do one of these, we can't make another one, we can make 2 more green ones though, and now we can't make any more. So that was fast, that was super, super fast. Now, with these games, you kind of want it to allow you to continue and getting more energy and stuff. So the enemies need to be worth energy. So we're going to create a C# script called energy bonus on destroy. And so this one, it's 9, but I'm just going to quickly wrap this up so that we can call this a game. Alright. And I'm sorry I didn't get the lobbying exactly. I'll probably have a little short thing where I say how to fix that up. You guys can probably figure it on your own too. And maybe half of you watching just think I'm an idiot at this point. So it's like, of course, it's super simple how to do that. I don't know why you didn't just do it this way. So if you have that, email me or something. I'll have my email at the end of the show here. So public float energy bonus, and all this does is void on destroy energy manager dot energy. The reason we can access this is because it's public static, so it just shows up here in the class name. It's a crafty way of doing it, and it's real quick and dirty. There's probably better ways of doing it, but just letting you know. So energy manager dot energy. God, energy is a weird word all of a sudden. You know how you look at them too long? I'm probably spelling it wrong too, but no, I don't think I am. It's just a weird word. Okay, energy manager dot energy. I don't know. Plus equals energy bonus. And that's it. And then we can attach this to each of our enemies. Where are our enemies? So we got basic enemy and fast enemy. And actually, I should have set a default here. So if I forgot, we got something out of it, but I'm not forgetting this time. So energy bonus, we're going to set the energy bonus to, for the basic enemies, we'll make them worth 100. Let's do 50. And then for the fast enemies, we'll make them worth 75. This is probably overkill too, but so now we can set up our slow tower, and then we set up like 3 shooty towers, and we get points, and then now we have enough to place more towers, and can't place any more up, and as soon as you can, it places them. And let's get up to enough to get one of our crazy mortar towers going. There we go. Late to the party, but it did fire. And yeah, that's tower defense. Basic tower defense, but it's all there. That's everything. Anyway, thanks for joining me tonight. I should always have one of these set up to show the... Actually, maybe I can do my fancy stuff. Do I still have that over here? Email screen. Does this do anything? I can't check my output. I'm going to type it in a you probably see the email on the screen right now. If not, my email is pushypixels@pushypixels.com or max@cookingwithunity.com, and Twitter is Drakfire. And let me just really quickly make this bigger. Size. I'll just do bigger until it's big enough. So, thank you for joining me tonight. Give me any feedback, criticism. Sorry that the episode was a little bit slow tonight, but we got everything in. So, thanks for joining me, and good night.